Now let's talk about what do we know by dimensions and dimensional formula. See, when I just described you the list of fundamental units, I'm writing only few now. I wrote mass, length, time, temperature and current. Okay. Now, dimensional formula represents the value of derived units in terms of fundamental units only, irrespective of what numerical value it has. For example, let's read out the definition first. Dimensional formula is an expression of character of a derived quantity about fundamental quantity. This statement represents how does a derived quantity or derived physical quantity is depending on fundamental quantities. Like I gave you a few examples of velocity. Velocity depends on length and time. Oscillation depends on length and time square. Then force depends on mass, length and time square. So this is just dependence thing. Okay, so character of a derived quantity about physical quantities without regard for its numerical value. That means we are not considering the numerical value. All we are considering right now is how the dependence is taken into consideration. Alright, so the dimensional formula is represented by this. For mass m, length, time, temperature Kelvin and current ampere. These are the dimensional formulas. So I'll write dimensional formula of few quantities. We'll start with velocity, acceleration, force, momentum, and let's write the dimensional formula for these four. Let's include one more, torque. Okay. Now, velocity, what is the SI unit of velocity? Velocity is meter per second. What is meter per second? Basically, it is length upon time. So I have to write it L upon T. So I'll be writing it as LT minus 1. What is SI unit of acceleration? It is meter per second square. So the dependence is L over T2, that is LT minus 2. Force is kg meter per second square. See, if I forget to, I'll come to that point. If I forget the SI unit, what should I do? I'll come to that point. So the dependence becomes mass, meter is length upon T square. So it becomes MLT minus 2. So these are the dimensional formulas. This is what a dimensional formula represents. It represents the character of the derived quantity. This is derived physical quantity about how they are depending on fundamental quantities. Okay. Now, suppose I don't know the SI unit. What should we do then? If I don't know the SI unit, all I'll be doing is I'll just remember the formula. What is momentum? Momentum is mass into velocity. Okay. So mass into velocity. So now I can write the SI units. What is mass? It is kg. Velocity is meter per second. So now I got the dependence kg, m, meter is length over time. So this becomes MLT minus 1. Torque. I still don't know the formula, so I'll be writing force into perpendicular distance. Force. Force is in newtons, perpendicular distance is in meter. But what is Newton? Newton is this, kg meter per second square. So I am getting kg meter per second square times meter. So meter square, right? This is what I am getting right now. So the dependence is kg is m, meter square L square upon T square. So this becomes m L square T minus 2. So this is how you can write the dimensional formula of any physical quantity you can think of. Okay. So now we'll come to a point where we have to know what uses these dimensional formulas are to us. For example, we'll start with the principle of homogeneity of equation. There are two different important set of questions which comes out of these dimensional analysis. One is checking the SI unit or finding the dimensional formula of any constant, and second one is deriving a formula using the dimensional analysis. First set is finding constants. Finding dimensional formula of constants. Now, according to principle of homogeneity of equations, principle of homogeneity of equations. This principle states that the SI unit or the dimensional formula of each term on left hand side of equation and right hand side of equation has to be equal. For example, I am taking an equation S is equal to ut plus half at square, and let's find the application or the genuinity of this principle of homogeneity of equation. So according to this equation, principle of homogeneity, according to this law, the dimensional formula of each term has to be same. Let's see. How do we represent a dimensional formula? Suppose I want to write the dimensional formula of S. So I'll be writing it in square bracket. So now if I would have written just this, that means I'm writing either the value or the SI unit. But if I'm putting it in square brackets, that means I want to write the dimensional formula. Okay. Now the dimensional formula of S is, what is S? It is displacement, is in meter. So meter is L. Now ut, let's talk about the dimensional formula of ut. What is u? Initial velocity. Velocity is meter per second, that is Lt minus 1 into time is t. So Lt minus 1, so here powers are getting added up, minus 1 plus 1 is 0. So I am getting just L. Whereas what is half at square? The dimensional formula of half at square is, this is a value constant, dimensionless if it is a numerical value, at square. A is meter per second square, that is Lt minus 2 into time square, which is t square. So I am again left with L because t minus 2 plus 2, t raised to power 0. So if I write it just this way or I write it m0 L t0, they both are equal, they doesn't change anything. So L, L and L. So now we know that the dimensional formula of each term of the equation is same, hence the validity of principle of homogeneity of equation is obeyed. Okay. Now using the same law, what we are going to do, we are going to first we are going to check the SI unit of some constants. For example, let's write a question. Ax is equal to bt square plus c upon, let's start with simple one, plus c. Okay, not c, let's write it v. Okay, here x is in meters, x is displacement and v is velocity. Now according to principle of homogeneity, each term should have same dimensional formula. So v, bt square and ax are going to have same dimensional formula. So we'll start with v. V is what? Lt minus 1. I started with v because this is the only term in the given equation, the dimensional formula is known to us. So I started with v. Then ax. What is ax? I don't know. So I want to write the dimensional formula of A and dimensional formula x in order to get Lt minus 1, but we already know according to principle of homogeneity that the overall dimensional formula is going to be Lt minus 1. So this is Lt minus 1. A, I don't know. X is in displacement, which is L, is Lt minus 1. So this gives me L cancel out or L goes here. So I'll be left with L1 or L minus 1, L cancels out. So I get dimensional formula of A is t minus 1. For bt square, again this has to be the dimensional formula, this term has to be equal to this, which is Lt minus 1. So dimensional formula of b into t square, t is time, so t square is equal to Lt minus 1, b is equal to Lt minus 1 over t square. This gives me Lt minus 1 minus 2, which is Lt minus 3. This is how we do it. We can find the value of dimension formula of any constant which is given to us in any equation by applying the principle of homogeneity of equation. Now one more thing. This time what we are going to do, we are going to derive a relation for anything. For example, now this is the second type of question which comes out in dimensional analysis. This is deriving or derive relation between physical quantities. Okay. For example, the question says that time period of oscillation depends on of a simple pendulum, let's say. So time period of oscillation depends upon number 1 acceleration due to gravity and number 2 the length of pendulum. So this is the factor which has been given to us. Time period of oscillation of a simple pendulum depends on acceleration due to gravity and length of the pendulum. So I want to find a relationship between time period of oscillation, the length of the pendulum and acceleration due to gravity. So this is how we do it. We will first write time period is directly proportional to acceleration due to gravity. That is true, but how is it depending on? They have just stated it depends on, not depends, it is depends. So they have just given us that it depends on. How does it depend? Directly proportional to square, it is proportional to root of g. They haven't given us anything. So for that per se, what we are going to do, we are just going to assume that time period is proportional to g by some factor, let it be a, as simple as it is. Then time period is also proportional to length of the pendulum, but by what factor we don't know, so this is b. So if we combine these two factors, I'll get time period is proportional to g raised to power a L raised to power b. Okay, that means t is equal to k times g raised to power a L raised to power b. This is simple up to this term. Now according to principle of homogeneity of equation, the dimension formula of each term in an equation in an LHS and RHS is equal. So whatever dimension formula is here, same will be applicable here. That's true. So what is the dimension formula of time period? This is t. So how I am going to write that? I am writing the dimension formula. I'll start with this. Dimension formula of t is equal to dimension formula of k g raised to power a L raised to power b, or k is dimensionless because this is a constant. Dimensional formula of g raised to power a, dimensional formula of L raised to power b, as simple as it is. So now I just want to write the dimensional formulas. T is m0, mass is not included in time period, m raised to power 0, length is also 0, and t raised to power 1. So we don't write 1, we just leave it like this because it obviously symbolizes 1. So m0 L0 t, this is what time period is. G is acceleration due to gravity. Doesn't matter if it is acceleration due to gravity or simply acceleration, the SI unit has to be same, that is meter per second square, or LT minus 2. This raised to power a and length is L raised to power b. So what do I get here? I get L raised to power a, t raised to power minus 2a and L raised to power b. So this L becomes a plus b and t minus 2a. This is how powers get added up and power gets subtracted. Here I am having m0, L0 and t. So by this equation we can equate the powers. By this we can see that mass is absent in right hand side. So there is no mass there. So we don't have to worry about m factor. All we have to worry about is a plus b is 0 and minus 2a is 1. So this is what we get. A plus b is equal to 0 and minus 2a is equal to 1. Minus 2a is equal to 1, that means a is equal to minus 1 upon 2. I've got one value, put a is equal to minus 1 by 2 there. So minus 1 by 2 plus b is equal to 0, so I get b is equal to 1 by 2. So I've got both the values. Put these two values in this equation. So the equation will be t is equal to k g raised to power a, which is minus 1 by 2, g raised to power minus 1 by 2 and L raised to power b, which is 1 by 2, right? This is the final answer. What is power 1 by 2? This is basically under root. So this is positive root and this is negative root. Negative root belongs to reciprocal of under root. So t is equal to k times under root L over under root g, and I can write it as not like this but the whole under root. So k times under root L by g. Now this is your final answer, but you are going to write one more sentence that the value of constant of proportionality can be figured out experimentally, and the actual relation is t is equal to 2 pi under root L by G. We cannot get, this is one of the flaw of dimensional analysis, that we cannot find the value of constants of proportionality, but we can find the value by doing experiments. And before doing experiment, by using the whole dimensional analysis, we can actually find a relation, because by this relation the value of K can be easily figured out. How? Keep K here and take everything that side. That means K is T upon under root L by G. So now you just put the values of T, L and G and you will find the value of K. So experimentally K is found out to be 2 pi. So this you have to write only if you know the actual relation. Otherwise you will write only T is equal to K times under root L by G, and the constant of proportionality can be figured out using experiments. Let's do one more question on the same thing. That the question given to us is, let me think of a question that okay, I'll think of a very simpler question, that torque depends on force and distance. Basically the whole statement was torque applied on a body is depending on the force applied on the body and the perpendicular distance from the point of application of force. So we need to find a relation for torque in terms of length, not length, yeah, basically length is the point of application of force, or perpendicular distance. So perpendicular distance and force. Give me a second, we'll just start. Okay, now same thing which I did here. I'll start with torque is proportional to force by what factor I don't know, so A. Is proportional to distance by what factor again don't know, so B. So torque is proportional to force raised to power A, distance raised to power B, and torque is equal to some constant times force into perpendicular distance, F raised to power A and R raised to power B. Now before this I've already given you the formula of torque. Torque is force into perpendicular distance. So from that we've already figured out the dimensional formula of torque, which was ml square T minus 2. We are going to use it same way. Here torque is ml square. Now before this you are going to write it in terms of dimensional formula, which is this is equal to K FA RB this, and then this is equal to this times this. After that you are going to do the final step, which is what is torque? ml square T minus 2 is equal to what is force? F is ml T minus 2 raised to power A, and what is distance? It will be L obviously, times B. So MA L A T minus 2A L B. I'll get A L raised to power A plus B and T raised to power minus 2A. This is equal to ml square T minus 2. Equate the powers, I'll get A is equal to 1 and A plus B is equal to 2. That means A is equal to 1, B is also equal to 1. So just put these two values in this equation. I'll get the formula straight away, that torque is equal to K times F into R, because both the value of A and B is coming out to be 1. So this is how you derive the equation or the relation between any physical quantities and derived quantities using the dimensional analysis.